Every question you have ever asked about the universe leads to an even deeper and more terrifying question. What was there before the universe began, and how does something come from absolutely nothing? These are not small questions. Scientists, physicists, and philosophers have spent centuries trying to answer them. The Big Bang Theory says the universe began from a singularity, a point of infinite density where space and time had no meaning. Einstein showed us that mass slows time, and the singularity contained all mass, which means time itself would have stopped. If time stopped at the singularity, then asking what came before the Big Bang may be a question with no possible answer. If the Big Bang is the beginning of time itself, subscribe to Noxar Flux right now. We release powerful space stories every single week. Quantum mechanics tells us that even empty space is not truly empty. Particles can appear spontaneously from a vacuum. Physicist Alexander Vilenkin showed that a small energy-filled vacuum could spontaneously appear and expand into a full Big Bang. The cosmic microwave background radiation is the leftover light from the Big Bang, and it is detectable in every direction we look. For every particle of matter the universe created, it also created antimatter, yet almost all the antimatter vanished, and we still do not know why. Coming up, we will ask the question that even Einstein found unsettling. Who or what created the nothing the universe came from? Scientists actually have 4 different definitions of nothing, and each one leads to a completely different answer about the universe. The most radical definition of nothing is a state beyond space, time, and physics itself, and science has no framework to describe it. Even in the deepest scientific vacuum, the zero-point energy of space remains, and that energy is what drives the expansion of the universe. If you use a physical definition of nothing, the universe did emerge from nothing. But the philosophical question remains permanently open. Everything we can touch, see, or measure was somehow created, and the process that created it may be completely beyond human understanding. Everything you have ever seen, touched, or measured makes up less than 5% of the entire universe. Around 25% of the universe is dark matter, a substance we cannot see but can detect through the way it bends light. The remaining 70% is dark energy, a force so strange that the more space expands, the more dark energy appears to drive further expansion. Dark energy may simply be a property of empty space itself, meaning the universe creates more dark energy every time it expands. The universe contains somewhere between 100 billion and 200 billion galaxies, a number so large it defies human intuition. Stay with us, because we are about to reveal where the center of an expanding universe actually is. When the universe expands, every point in space moves away from every other point, which means the universe has no single center at all. Every observer anywhere in the universe sees themselves at the center, because the expansion is happening in the fabric of space itself. Current scientific evidence suggests the universe is flat, not curved, meaning it extends infinitely in all directions without looping back on itself. The cosmic microwave background radiation gives us the strongest evidence that the universe is flat, with almost no measurable curvature. A closed universe curves back on itself like a sphere. An open universe curves outward like a saddle. Ours appears to do neither. Even if the universe is infinite, we can only observe a sphere about 93 billion light-years across from our position in space. Some galaxies are receding from us faster than the speed of light, not because they move through space, but because space itself is expanding between us. Our own Milky Way galaxy is on a collision course with the Andromeda galaxy, an event expected to unfold in about 4 billion years. When the two galaxies merge, most stars will not collide because the distances between individual stars are unimaginably vast. Future beings inside that merged galaxy will look out and see only blackness, with no evidence that billions of other galaxies once existed. We are looking at a universe so vast that 94% of the galaxies we can currently see are already forever beyond our reach. Scientists have determined the universe is approximately 13.81 billion years old, and we know this with a margin of error of just 40 million years. We measure the universe's age by tracing its expansion backward in time, combining data from ancient starlight, galaxy motion, and background radiation. The oldest star clusters in our galaxy appear to be around 13.2 billion years old, which independently supports the 13.8 billion year age of the universe. When we look at a galaxy 2 billion light-years away, we are seeing it as it existed 2 billion years ago, not as it is today. Here is where it gets truly strange. Is the universe the same age for every observer? Or could some parts of the cosmos be dramatically younger? For any observer not moving at extreme speeds, the universe appears to be 13.8 billion years old in all directions, a consistent cosmic truth. But if a galaxy has been moving near the speed of light since the early universe, time dilation means it could be billions of years younger than everything around it. Einstein's general relativity changed everything we knew about time, showing that motion and gravity can fundamentally alter how quickly time passes. General relativity mathematically allows for time travel, wormholes, and closed loops in space-time, though making any of them practical. A rapidly spinning black hole drags space-time itself around it, creating pathways that mathematically allow a traveler to return before they departed. Remarkably, just 6 mathematical parameters are all we need to describe the entire observable universe with stunning precision. The optical depth parameter tells us about the first stars that ever formed, and the intense radiation those stars released into the early universe. The first stars were likely hundreds of times more massive than our Sun, burned for only a million years, then exploded and seeded the universe with heavy elements. Every atom of carbon, oxygen, and iron in your body was forged inside a dying star and scattered across space by a supernova explosion. Rocky planets capable of supporting life could not have existed until enough stellar generations had lived and died to produce the necessary heavy elements. We are about to reach the most personal question in all of science. Are we alone? And was this entire universe somehow made just for us? Space telescopes have confirmed the existence of thousands of exoplanets, and scientists estimate there are billions more throughout our galaxy alone. Organizations have been scanning the sky for radio signals from intelligent civilizations since the 1980s without detecting a confirmed signal. The Fermi paradox asks this: if intelligent life is common in a universe this vast, why have we heard absolutely nothing from anyone out there? Within our own solar system, moons like Europa and Enceladus have subsurface oceans that could harbor microbial life right now. Rovers actively exploring another planet are searching crater environments for chemical signatures that ancient microbial life may have once existed. The physical constants of the universe, the strength of forces, the mass of particles, appear to be tuned with extraordinary precision for complex life to exist. The multiverse theory suggests that if infinite universes exist with different constants, we simply find ourselves in one where the numbers allow for our existence. We are a civilization on a fragile planet in a vast cosmos, asking questions that may only have answers beyond the limits of what we can ever observe. Carbon, the element essential to life as we know it, did not reach sufficient abundance until the universe was already 1 to 2 billion years old. 94% of all the galaxies we can currently see have already passed beyond our cosmological horizon and are forever unreachable. Coming up, what lies beyond the observable universe? And could anything we know about physics prepare us for what might be out there? The universe we observe is about 93 billion light-years across, but the full universe is estimated to be at least 10 to the power of 23 times larger. The most scientifically straightforward possibility is that beyond our observation limit, the universe simply continues with more galaxies, more stars, and more planets. In a puzzling phenomenon, astronomers observed entire clusters of galaxies all streaming in the same direction. Possibly pulled by something massive, the multiverse theory proposes that our entire universe is one bubble among countless others, each born from the same eternal inflationary process. String theory requires 10 dimensions of space-time to be mathematically consistent, with 6 extra dimensions coiled at scales far too small to detect. A wormhole could theoretically connect 2 different universes if both are connected through the interior of a black hole. Particle accelerators search for heavier versions of known particles that would only appear if extra dimensions exist at subatomic scales. Next-generation space telescopes will look back to within 200 million years of the Big Bang, revealing the universe's first structures ever formed. Physicists have identified 3 primary fates for the universe: the Big Rip, the Big Crunch, and the Big Freeze, each more final than the last. Stay with us through the final act, because the most probable fate of our universe is something far stranger than destruction. It is eternal silence. The Big Rip scenario predicts that if dark energy continues to strengthen, it will eventually overcome gravity and tear apart galaxies, stars. The Big Crunch scenario envisions the universe reversing its expansion, with all matter collapsing back toward a single impossibly dense point. Some researchers have calculated that a phase transition in the Higgs field could already be underway, silently spreading through the cosmos at light speed. The Big Freeze is considered the most likely fate. The universe expands until gas reserves are too thin to form new stars, and all energy gradually equalizes. In the Big Freeze scenario, time becomes an infinite expanse where nothing happens, because there is almost no usable energy left anywhere in the universe. Beings living inside the merged future galaxy of our local group will look out and believe their galaxy is the entire universe, with no hint of the wider cosmos. They will have no knowledge of the Big Bang, no awareness of cosmic background radiation, and no evidence that 2 trillion other galaxies once filled the sky. We exist at an extraordinary moment in cosmic history, one of the only epochs where the full scale of the universe is still visible to those who look up. The fact that we can ask these questions at all, and that the universe has produced minds capable of wondering about its origin, is itself one of its greatest mysteries. The light from the Big Bang itself still surrounds us, a 13.8 billion-year-old echo that fills the entire sky. We are made of star material, living on a pale blue dot, inside one of 200 billion galaxies. If the unsolved mysteries of our cosmic origin moved you, subscribe to Noxar Flux so you never miss a story. New space documentaries drop every single week.